right away you can see that this one's pretty different from the other three. And the biggest difference is that there's not any kind of log expression here. On a problem like this, what we're going to actually try to do is a different technique. We're going to look at this 125 and this 25 and notice that I can write these two different sides with a common base. I'm not going to use logs here at all. I'm just going to recognize that this can be written as 5 to the third. 5 times 5 times 5 is 125. And this can be rewritten as 5 squared. And of course, we can't forget about that x plus 4. We still have to think about that. But the idea on these types of problems for this section is they're going to give you problems where the numbers here can be rewritten with some kind of a common base. So you'll do that. I want you guys to know something. I haven't really changed the value of anything. I haven't added or subtracted anything. I just changed the way I'm saying 125, it's 5 cubed, and I'm changing the way I say 25, it's 5 squared. Now I'm going to clean some things up. This is supposed to look more like an x. So the 5 to the third, I'm going to leave that alone. And on this right side, I've got a power raised to a power, and I know that if I have a power raised to a power, like for example, if I had a squared to the third, I know I would multiply those powers together and make it a to the sixth. This is the same idea. I'm going to take these two powers and multiply them together. So this right side will be 5 to the whatever 2 times x plus 4 is, multiplying these two powers together. That's going to give me an expression like 5 to the third equals 5 to the, if I distribute this, 2x plus 8. Now you might be wondering where we're going with all this, but the idea is if I have the same base on both sides, like I do, and they're raised, then they have to be raised to the same power if they're going to be equal. So if these two sides are going to be equal, it has to be true that 3 has to equal 2x plus 8. Right? Because if the bases are the same, then the powers have to be the same. So I just have to find the x value that makes this equal that guy's power. And now this looks very much like a problem that I've solved many, many times in my life. And it's all thanks to the fact that I was able to take the original problem and rewrite these numbers with a common base. So let's go ahead and finish this thing off. I'll subtract an 8 from both sides. So if I subtract 8, the left side becomes a negative 5, equal to 2x. I'll divide both sides by 2. X will equal negative 5 halves. So again, we're trying to take a problem we don't know how to solve, use some elementary math skills from middle school, and turn it into a problem that we do know how to solve to make our lives nice and easy. We're not changing the value of anything, we're just changing the way we say things. I'm not going to say 125, I'll say 5 cubed. I'm not saying 25, I'll say 5 squared. And then of course this property about powers to powers being multiplied comes into play. So play with that, be patient with yourself, and good luck.